Welcome friends. We are going to solve examples based on electromagnetic fields. This is third video in this series on vector analysis. Example 3. Uh, this example is based on cross product of vectors, calculation of area of triangle and unit vector perpendicular to the plane containing the two vectors. So in example 2, earlier in the other video we have seen the definition for the dot product. Now this example is based on cross product. So let us move ahead and refer to the question. So the question is like this. A triangle is defined by 3 points, point A, point B and point C, and we are supposed to determine the cross product of vector RBC with vector RBA as a first part. The second part, second sub question, we have to find out the area of triangle formed by points A, B and C, and lastly we have to find out a unit vector perpendicular to the plane in which the triangle is located. So this unit vector is actually a vector which is perpendicular to the plane containing vector RBC and vector RBA. So all these computations they are related to computation of cross product. So let us consider evaluation of cross products as a first part. So for the cross product we require two vectors, that is vector RBC can be obtained as vector RC minus RB as position vectors, 3AX cap plus AY cap minus 3AZ cap, and vector RBA similarly can be obtained as vector RA minus vector RB, so that is 5AX cap minus 7AY cap minus 3AZ cap. By definition of cross product for the two vectors in Cartesian form, we have to write a determinant wherein the first row is occupied by AX cap, AY cap, AZ cap. Second row is occupied by the X, Y and Z component of vector RBC, that is the first vector in the cross product, and the third row is occupied by components of vector RBA, that is 5 minus 7 minus 3. Then we solve this determinant as a standard practice. So on substitution and solving the determinant, we are able to evaluate the cross product as vector RBC cross vector RBA equal to minus 24 AX cap minus 6 AY cap minus 26 AZ cap. So by knowing two vectors in the Cartesian form, the evaluation of cross product can be carried out by using a determinant method. The first row are the standard unit vectors AX cap, AY cap and AZ cap. Second row is components of the first vector along X, Y and Z direction, and similarly third row components are for the second vector involved in the cross product along X, Y and Z direction. So on substitution of these components, the determinant can be 3 by 3 determinant, the standard way of solving it as we apply will be able to obtain the cross product. So let us review the question. The question is about 3 points, point A, B and C. So we have to find out the first part. We have to find out the cross product of vector formed by vector points joining point B and C, vector RBC with RBA. Then area of triangle ABC. Thirdly, a unit vector in the perpendicular to the plane in which the triangle is located. So for this, we first express vector RBC from coordinates of point B and C as RC minus RB, as we did in the first example in the other video. Similarly, we determine vector RBA from coordinates of point B and point A, and then we write the definition for the cross product, substitute the coefficients of vector RBC and RBA in the determinant, and then go for simplification of this determinant and obtain the cross product. The cross product is obtained as minus 24 AX cap minus 6 AY cap minus 26 AZ cap. Let us now move on to determine the area of triangle by using the result of the cross product itself. So let us observe based on the diagram. We are trying to represent here vector RBA and vector RBC, with vector RBC shown as a base, and we drop a perpendicular from point A onto a line joining point B to point C. So in order to find out the area of a triangle, we know the definition that usually the area of triangle is evaluated between 3 points, point A, B, C, as half base into height. So in this diagram we can clearly see the base is length of vector BC, that is mod of vector BC, and assuming that angle between vector BA and BC is theta, we can express height to be vector RBA sine theta, or length of vector RBA sine theta. So that's why here we are expressing half base into height. So base is mod of vector RBC, and perpendicular drop from point A, that will form the height as mod of vector RBA sine of theta, assuming theta to be angle between these two vectors. So from the definition of the cross product, we know that cross product is expressed as product of magnitude of two vectors, sine of angle between these two vectors, and a unit vector perpendicular to the plane containing the vectors involving cross product. Okay, following the right hand screw rule. So area of triangle can be understood as magnitude of cross product of two vectors. So we express mod of vector RBC cross RBA instead of base and height, with base being mod of RBC and mod of RBA sine theta forming the height. So we get the area to be 17.9443 meters square. Next we move on to calculate a unit vector perpendicular to the plane containing the triangle. So as I told you that unit vector containing a plane perpendicular to the plane containing triangle can be obtained as a vector along the cross product or vector product result of vector RBC and vector RBA. So this vector RBC and vector RBA, we substitute the cross product as obtained in part A and divided by its magnitude, we obtain a unit vector A cap n to be minus of 0.6687 AX cap minus 0.1671 AY cap minus 0.7246 AZ cap. So unit vector perpendicular to the plane containing triangle is simply visualized as a vector perpendicular to vector BC as well as vector BA, and such a vector can be directly obtained as unit vector corresponding to the cross product of these two vectors. So cross product divided by its magnitude, that gives us the value of vector A cap n. So this way we are able to calculate the cross product in part A, the area of triangle in part B by using magnitude of cross product, and unit vector in part C. Let us review this slide. We found the area of triangle as half base height. So base and height are obtained as a magnitude of cross product, that is mod of RBC. So 1 by 2 mod of RBC cross RBA. This mod of RBC cross RBA is nothing but magnitude of cross product obtained in part A. So we substitute it and simplify like this: under root 1 by 2 under root 24 square plus 6 square plus 26 square, it comes down to 17.9443 meters square. Next we evaluate a unit vector perpendicular to the plane containing the triangle as simply cross product vector divided by the magnitude of cross product. So we substitute in the numerator as minus 24 AX cap minus 6 AY cap minus 26 AZ cap divided by its magnitude, and try to simplify it. Finally, to obtain the unit vector as minus 0.6687 AX cap minus 0.1671 AY cap minus 0.7246 AZ cap. So this way we learn how to apply the cross product in evaluating the area of triangle and obtaining a unit vector perpendicular to the plane. Uh, so thank you for watching this video. If you think it has benefited you, then please like and subscribe this channel and keep watching for further videos in future. Thank you.